So the objective of my talk is to basically answer three questions: the what, the how, and the why. I'm going to go through in the how a little bit about the language itself, but I also want to talk about the why. So I'm going to focus on that as well. And I'm also going to use a lot of material that Elastic's put out, because they've actually put out quite a bit, but I don't think it's been displayed enough. And we're going to have some links and stuff that you guys are going to have access to later of where I got it from and what webinars they have out as well. So the first thing is, what is EQL? What is event query language? So here's a traditional view of a Kibana graph, right? Time series data. You have time and then some sort of value. Okay. And then your queries, they would find events in that series and find the value. You know, if you could think of it like a function, right? You know, here's time as your X, and then your value would be on your Y. So think of it like a two-dimensional graph. Okay. So the problem here is that your relationships could only be through time on single event types. You couldn't really say, look at your endpoint data and your network data at the same time in a single series in the rule. There were barriers to doing things like that. So obviously creating patterns inside alerts, things like that was very difficult. So I'm going to show this because what EQL really does is it adds a whole nother axis to this graph, right? So now in EQL, you can pivot not only between time and whatever value in that field you're looking at, but you can pivot between event types. And what I mean by event types are things like a process, or you know, if you're looking at a file event or you're looking at a network event. And we'll get in that with the syntax. The important thing to remember is that you can find more complex relationships in the data this way. And beyond that, and I'm going to get into this in my third section on why this is so awesome, is that it means that these rules can actually be chained together into patterns of adversary behavior that can then be looked at in a three-dimensional vector space that can be used for some really cool mathematical analysis. So what we're going to look at here is, whoa, that was not nice. Okay, so what we're going to look at here is Endgame creates EQL. So Endgame originally created EQL as a schema-neutral query language. It was specifically designed for threat hunting and security detections. And I've actually put a picture there from their original GitHub page, because event query language, it exists as its own query language. It's not schema specific. It was really made so it could look at any data set. And the data sets could come from anything. It could be Sysmon data, it could be endpoint, you know, if it was your endpoint agent, it could accommodate any data set. And they actually have a Python tool that actually makes up the language and can be applied that way. Now, obviously, when Elastic and Endgame, you know, we became one, as you might say it, a subset of EQL was designed for Elasticsearch. So there are certain functions that are not incorporated into Elastic's version yet. Some of them are going to be incorporated later, and some of them may not fit quite with the way the indexing works. It's yet to be seen. So now we're going to go into how to use EQL. And first, I want to give a super duper thank you to James Spiteri and Ross Wolf. They're both employees at Elastic. And one, they are always on the community Slack answering questions. specifically EQL, any detection rule questions. They're on there. I mean, I almost wonder when they're not on there because they're always there when we have questions, and it's wonderful. And they provided a wonderful guide um, that helps with understanding EQL and its syntax. And I'm actually going to use the examples from that guide because why reinvent the wheel when someone's made an awesome sports car, right? And then there's also a wonderful webinar that was done by Ross and a fellow engineer that had come from Endgame. And they show some of the advanced features too, which is wonderful. So let's actually look at the basics here. So this is your simplest form of an EQL search query. So this is what we mean by denotes the event category. Notice a process, and then when it says where, that means it's going to be where is your basically like your chooser. You know, you're saying it's going to be this in this field, process name. Then you use the two equal signs, and then here it's looking for a string. So the nice thing about this is how simple it really becomes to write these rules. I know in the past when I've discussed Elastic with other security practitioners, they've always complained about the complexity of some of the query languages, especially, you know, the ones that get a little more, you know, they need a few more symbols, let's say, than some other simpler query languages, especially some people who come from SQL backgrounds, I've noticed. So I really think EQL comes in and just simplifies things. Now notice here, for instance, if you don't want to look at a specific event type, you can just add any. So now instead of just looking at process events, and this is where it comes from, the event category, by the way. Now we're just looking at any event where the process name equals that value. So that's pretty powerful to be able to change it with one word, right? Like just straightforward. Now this is my favorite new feature in EQL. This is something we've not had before. And in my opinion, it's its most powerful feature, which is sequences. And what you're able to do is you're able to, first of all, define the sequence. And you're going to be looking at username. And that's the field that you're basically going to match across the query. So you're saying, take username, right? And tell me all of the events that now have these next sequence of values. Okay, and it will actually organize them by the various usernames that match, you know, when it returns the results. Now here's time. Okay, so we talked about those axes, right? So here's time, right? Max span 15 minutes here. So you're looking at a span of 15 minutes. Then here's your event type, a file, event category, okay? Where, and then your field, file extension, and then it's going to equal, again, here, exe, but some value. So we have all three of our axes. We have our event categories, because it keeps going. We go process, where true. Now, when you put where true, that just means any time that there's a process event category. So what they're saying is that do a sequence by username. So it has to have a username in it, and it's organized by username. That's across 15 minutes. Then we want file category, where this is the extension. And then here, actually, it's any of those that have a process in them. So if any of these, first, you look through these because it's top to bottom. Any of those that have the category of process are going to be returned. If they don't have a process in them, then, you know, it's not going to be returned. And then finally, an authentication category where the event outcome is success. So you're looking for successful authentication that starts a process, the file extensions exe, and organize the sequence with username in the last 15 minutes. So you're pivoting between time, event categories, and the values themselves. And that's an amazing capability that we never even dreamed of before. So this is an example that they put in the guide that I think is really awesome because it shows how you can actually combine multiple data types. So here we're defining again the sequence, and we're doing it by process entity ID. So we're looking for category is process, where event type start, and process name in, which means it's going to have one of these. Okay. So first we're doing, we're organizing everything by process entity ID. Then we're looking for a process where event type is start. Then we're looking for these specific process names or some form of them. Now here's the cool part, right? Then we do a pivot into a whole nother event category, network, where network protocol is DNS. Because what are we looking for? We're looking for that wonderful command and control that's being run by one of these, right? A process that is causing a DNS query, but it's being caused by, some sort of executable that, hey, maybe we don't want that to be making a DNS query like PowerShell or install util, things like that. And so this really shows that power to not only create single detections looking for one piece of the bad behavior that we're looking for, the bad stuff going on in our environment, but how to start chaining those events together to make patterns. Start looking at, like, for instance, with MITRE ATT&CK, start looking at the progress of the attack. Start looking at what comes, maybe not sequentially, but at least pattern wise. What's the adversary playbook, for instance, is a common term. You can actually start making queries that look for those playbooks. Now here is something that and it's interesting that we bring up things like cross cluster abilities and such, because one thing that we used to not be able to do definitely with a query was we couldn't look across multiple indices. And that was a problem because our network indices was one place, and our indexing for, say, WinLog beat might have been somewhere else. But because we have elastic common schema now, we can look through them and just, define the data. This is what I was trying to get across in a previous talk I did on Fleet and the Elastic Agent. But all of these events are just data. And anybody who knows the history of Unix knows that the biggest improvement in the history of operating systems with Unix was that they decided everything was a file. They wouldn't worry about where the file came from. They would treat everything as a file. And it totally simplified how the computer operated. And that's the beauty of EQL, is that all it does is look for these events and these values. And now we're using the power of elastic common schema in this particular setup. But like I said, in reality, the language is the power, because when combined with a common schema, then you really get its true potential. But still, it's the language that makes this possible, because we're able to set this sequence and then use a by process parent ID here, and then pivot to network, the network category, where there's any network category, and then of course by this value here. So this is It's not a complex query to read, which is the beautiful part. Again, I mean, it's pretty straightforward what it's doing. It's using a wildcard here. What's nice is wildcards can be used to kind of help with text patterns, your regular expression. They have some other operations. I really suggest you take a full look at the guide. I didn't want to try to dive into it all tonight in the time span I had. I am going to be writing a blog that will kind of follow up with this talk. And in it, I'm going to be showing how to make original rules that I'm working on that have to do with defensive evasion. But like I said, I didn't want to, get too involved here. But the other thing, which is nice about this, is it's now going to be case insensitive, meaning that that was one of the issues that some of the detection engineers who have worked on the Sigma project and also with some other threat hunting projects there was the concern about the keywords not recognizing when there was an uppercase or lowercase. So a potential adversary could actually get around your detection by just changing the cases. And that was a problem. There was a third-party fix on some of it, but now with EQL, it's inherent now. We can deal with that situation. Here's the other cool thing. The Elastic Rules department has created a repository that all of us can use and contribute to. And this is really awesome for a couple reasons. One, it really helps us stay ahead and not repeat everybody's work over and over again. Because let's say I'm working on defense evasion rules. And let's say the Elastic team is working on defense evasion rules. And let's say Chris is working on defense evasion rules. Wouldn't it be nice to actually know that all three of us are working on defense evasion rules so that we're not repeating, we're not wasting resources? And maybe we have different ideals that could feed into each other. And so the repository is so much more than just a list of rules. It's a place where you can actually start feeding into each other's ideals and really expand the rule set in an orderly fashion. Now, the other neat part is that it's not just a list of rules. It's actually an entire Python application where where you basically have a form type setting where you write the rules. So it helps you with creating the TOML that they're based in. They have Python code that tests the rules, and they even have the red team automation code, which was a program developed by Endgame that they would use for adversary emulation. So if anybody's used, let's say Atomic Red Team automation is another type of kind of atomic testing to to make sure that your rule is actually firing the way you think it's going to. So this is a very powerful set. So don't think of it just as another rule repository, because I know there was some worry about this when it came out. Oh, Elastic is just trying to make its own rule repository and, gather up all the rules now. And that's just not true, because it's more than that. It's testing of the rules. It's validating, the way you're writing it. It's really making the rules as efficiently run on the Elastic platform as you can. And definitely, I know I'm a big follower of Sigma. I'm a big supporter. I've been on some of the sprints. And for me, when I develop a rule, I'll make a Sigma version, send that one off to their GitHub. And then when I contribute here, it's under the Elastic license, and I'll be happy to contribute here and work on the rule here. Because in reality, they're very two different use cases, right? I mean, one's, Sigma, which is a detection language that's, neutral to any platform. And so you have to write them a little differently. But on here, we're optimizing them for Elastic, and we're also, meeting the needs of the stack itself. So finally, the biggest question I think that should be on your mind. Why should you care about EQL? What is it about event query language that has people like me basically dancing around when we're working? So I bring it, Master Windu. You must realize there aren't enough Jedi to protect the Republic. We are keepers of the peace, not soldiers. Exactly what we should be worrying about. There just aren't enough resources, not just human resources, but capital resources to deal with alert fatigue, evolving threats. And the biggest one in my mind is stopping the approach of cybersecurity where it's clean up on aisle 9, right? I mean, how many times is it going to be after the breach that we start going, oh, we could do this or we should be doing that? And obviously, there's more to it than just detection, but it's definitely a place where, you know, we can make a huge impact, especially with alert fatigue and dealing with evolving threats. I mean, we all just saw what happened with SolarWinds, and, you know, we all talked about the threat of a supply chain attack like this for a long time. And so now we're dealing with, the aftermath of, what could we have done? How are we going to prevent the next SolarWinds? How are we going to look at things differently? And I know for myself, that's why I'm focusing on defense evasion in the next set of rules I'm going to work on, because I've noticed that that's a possible bottleneck that we can create for different malware. Because in reality, the things that like, for instance, the SolarWinds, the various malware strains do, there's a lot of things that applications shouldn't be doing, even if they're trusted binaries, in the defense evasion stage. So that's one thing I'll elaborate a little more on in the blog I'm going to be putting out as a follow-up to this talk. But this is one of the main things that I worry about, is there's just too much out there, right? I mean, and for instance, like, you can't take something like the MITRE attack framework and try to defend every tactic and technique. You're going to go crazy. You're never going to make it to where you need to be. So you really need to have a query language that allows you to focus on the actual threats and patterns of threats that you're going to be seeing in your environment. Now, I'm also going to talk about some advanced research that I'm doing. So that's the next section here. So I want to talk to you about what is a detection, okay? Because you might think about it in some ways, but I want to talk about an interesting way of thinking about it. So the first common answer is that it's a possible event, because, it could be a false positive, that may indicate malicious behavior. And that's fine, but in my opinion, that leads to an approach that almost opens itself up to alert fatigue. So I don't like that one. Next, we have, it's a part of a chain of adversary behavior. Okay, we're getting a little better because now we're looking for behaviors. Maybe we can create some playbooks that we can look for, and that's good. But I think the problem there is that we're still going to be limited to our own creativity, our own biases. And so, to me, we need just one more step in understanding how we can help the daily analyst. How do we take things like detection engineering, threat intelligence, and how do we make them matter on the day-to-day ops level? Because that's actually an interesting topic I always get into often. Here's the third one, and this is what I really like. It's a decision to be made by an analyst. So in reality, in the end, a detection comes down to a decision. Okay. And it's a decision based on the probability of it being part of an adversary chain of events. And an analyst has to make that decision. And I really believe that what we should be focusing on is creating alerts that give as much information about what risk level is most probable, and um, focusing on looking at not just giving the alert, not just giving, say a score for the individual event, but actually creating chains of rules that are modified, first of all, for the exact environment they're in. And second, that are modified as, again, to spread out possibilities. Now, of course, again, this is on a rather theoretical level that I'm talking about studying the rules, but I really think that the conclusions from it can be very powerful. So one tool that I've created, and I actually gave a lightning talk about this at MiterCon. Sorry, not MiterCon, AttackCon, that's what it's called. AttackCon in 2019. It was AttackCon 2.0. And I got to give a 5-minute lightning talk on what I call attack poker, because I see the battle between the adversary and the defense in the blue team as a game of poker. The cards in this case have been abstracted into miter attacks, tactics, and techniques. And then the risk that you're going to take is what you're going to bet. How certain are you that you know what's going to happen? And the reason I chose poker is, one, I like patterns of 5. I feel that 5 is a good chain of events to where you can probably know where things are going. Second, it's a game that a lot of people are used to playing. They have a feel for it. And then finally, third, poker, unlike other games like, let's say, chess or other strategy games, has a human element to it, right? You don't just play on probabilities. You're not just counting cards like blackjack. You're not just counting possible moves like in chess. You are literally playing against the human persona. You're playing, you're bluffing. There's a lot going on in it. There's a great Star Trek quote where they're going up against this alien, and they basically claim to have this self-destruct device that they don't have. And before Kirk comes up with the Koberite maneuver, they say, is it chess? It's checkmate. And Kirk says, no, Mr. Spock, not chess, poker. And so I really think that the game theory of poker and the decision-making processes of poker make a difference. Now, I'm going to go a little bit into my math and physics background here. So do your best. I have a picture that gets it across. I was hoping to have the video, but demo gods were against me. So one thing I want to do with the data that is collected from attack poker, from analysts playing the game and making those decisions and such, is be able to apply, again, looking at probabilities, being able to apply fluid dynamics to the events. So what I want you to do is think of a chain of events like a molecule, right? And each event is like an atom connected to it, okay? And then the adversary patterns determine the geometry of the bond. So like, think of the old, hydrogen with 2 oxygens, atom that you had in chemistry class. And think of those atoms as your events, and they're connected somehow. So this is a picture from a program called Houdini, which is a 3D content creation program that does a lot of cool visual effects. Now, I was going to have this way better done in the video, but I just drew in where the points would be so that I could visualize it a little better for you. So, in any single period of time, it's a puff of smoke. Okay. So imagine the smoke as if you had complete information about everything in your environment. You knew everything going on in that slice of time. Unfortunately, in the real world, we never have all that information, right? We don't see the puff of smoke. But the puff is because, well, what does smoke do? It diffuses into the atmosphere and you can't see it anymore. Data is a lot like that. In that single moment of time, the data exists in your environment somewhere. The logs or the detections or the activity, all the data exists. But can you necessarily see it? Probably not. Are you making the decisions to act on the proper alerts? Maybe not. So, but what I've done here is mark certain events that are derived from the minor attack framework of an adversary's movements, in the environment, tactics and technique wise. Now, the cool thing about this is that the movement of these points will be determined by the movement of the smoke. And that's why it's fluid dynamics. Anytime you're calculating the movement of smoke based on temperature, density, things like that, we call it fluid dynamics. It's a really well-known field because remember that graph I showed you of the three axes of time, event, category, and then value. Well, what we've done here is we've combined them to include the decisions that analysts are making based on the risk. So remember attack poker, it has the events, it has the values, it has it over time, but it also includes what decisions are being made. And that's what I think is important here, is that then we look at those points over time and we can start imagining why are we missing these things? Because once we have a model, like let's say you didn't have these two, right? Let's say you only had these three. Well, the funny thing is that we know fluid dynamics really well. And if we calculate the probabilities of where this point's going to go, we can start realizing that there's a point up here. So you can start predicting what data you're not seeing. It's kind of like when you look for a planet with a telescope, right? But you don't have a powerful enough telescope to see the planet. So what do you look for instead? You look for wobbles in light from the star, because that means there's probably a planet there. And so you can actually do the same thing with this same model. Now, why did I choose fluid dynamics? You might be wondering why on earth I think that data can be modeled with this. And it actually goes back to the founder of information theory, Claude Shannon, in 1948. In Bell Labs, obviously, he published his Mathematics of Information Theory. And what he showed was that there is a mathematical law of information that is very similar to the structure of entropy. So in information theory, there is an understanding of what entropy is in data. And so I was inspired by that to realize that if there's a concept of entropy, then there must be a concept of the other main rule of thermodynamics, which is the conservation of mass and energy. So I said, wait a minute, that means there has to be a conservation of information. So if you can't see the information, it still has to be there. There still has to be some sort of relationship between what you can see and what you can't. And if we model it properly, then we can start creating detections that are going to help the analyst understand not what they see, but what they might not be seeing. And so that's a very powerful tool that this will hopefully develop into. And I know it seems kind of odd to be using, you know, 3D content creation tools. I'm actually rendering the whole thing in the Unreal 4 game engine and using their particle system. In the future, like I said, the demo gods weren't with me, but in the future, this part of it will be a particle system in Unreal 4. So the data, the point data for this cloud will actually be used with these here. And the conservation of information exists because even though the cloud dissipates, these points and these connections between the points, they don't go away. They don't disappear. It's just harder to see them, right? I mean, for instance, if you have an adversary, a spot on breach and it happened 6 months ago, it's going to be harder to see, right? The smoke is more spread out. And so that's the concept here. And I think, yeah, I'm done with that. So I will open it up to Q&A, and that was fun. Thank you for having me.
Cool. Chris has a couple questions.
Okay.
Chris, you want to ask him directly? I'll let you, if you would like, maybe expand on your question too, if you want.
Okay. Yeah. Let's see. So it looks like it's you're interacting with the Elasticsearch via a Python interface, and you can set up your queries in various YAML files, I guess, or you're using the EQL. Does it require anything on the Elastic side, or is all the translation happening within the Python library?
Okay, so if you use the Python repository, it will generate the TOML. Actually, it's TOML.
Okay.
Which I was wondering why as well originally. Maybe why they didn't choose YAML, but TOML is actually a lot more flexible than YAML. It's easier to work with. And what it will do is they actually have a tool in here where it will generate the TOML for you. And then it actually has it says right here, actually, the Python library for handling the API calls to Kibana and the detection engine. So you can actually upload your rules that you write and test right to your Kibana deployment. So you could actually run, create detections using this tool and then automatically upload them into Kibana. Now, obviously, you can write your detection rules in Kibana as well, using the GUI interface. But, this just gives you, especially if you're on, if your whole thing is, you're on your detection team, you're working with rules, you're testing them out, especially if you want to help, again, with the community and adding them in, then this is a wonderful tool.
Okay, so it converts it into a KQL format then, I guess, is what it's doing, right?
No, it'll be an EQL.
It's an EQL.
Yeah, or EQL, you can use EQ. Oh, sorry, I didn't mean to talk over you.
No, is the EQL being processed in the Elastic Engine, or is it being converted into KQL through the Python library, and then that just turns into whatever the query is?
No, the EQL is being processed by Elastic itself.
Oh, okay. All right.
You have an option whenever you write a rule, a detection rule, whether you do it in the Python from the Python repository or the detection engine in Kibana, you have a choice of your query language. You can use Kibana query language. You can use, I believe you can use straight Lucene. And then also now we can use EQL.
Interesting. Okay. And I guess my other follow-up question to that was, obviously you have a security bias to the use of this? Have you seen this being used in other non-security based type data sets?
Yes, actually. We just had a discussion in the community Slack about using it for metrics, which is wonderful, actually. Obviously, it has a security, foundation, but in my opinion, this can be applied to any data set, especially because we have, elastic common schema, and we have, this understanding that again, like I was saying, when you're just looking at your data, right? We're not worried about, is it security data? Is it observability data? EQL is really just about looking at those time series events. And so I definitely think that EQL can be expanded. Definitely, if you have a use case that you're interested in, your best bet to get some feedback on it from Elastic is come on the community Slack and just talk about it. Because that's what we do all day. We just geek out on EQL.
All right. Yeah, sounds like
But yeah,
fun.
no, I know for a fact we had a discussion about metric the other day.
Yeah, I have so many distractions during the day, but I do like the way the EQL is formatted. It's definitely, like you were saying, it's a lot more readable as opposed to some of the raw KQL is very long. So
Yeah, it gets a little verbose.
yeah. So, and you get unbalanced with your curly braces very easily. So, okay. Is there? So I guess if it is independent of KQL then. So it's not.
Correct. Yeah, it's its own language.
Right. So obviously its strength is you're able to bring in that third metric very easily and apply it, or fourth metric. Is there a limit to how many n type relationships you want to make at all with EQL?
That's a very good question. I don't think it's so much is there a limit as what would be the performance.
Right.
I think it would be more about a performance benchmark at that point.
Okay.
Because, like I said, I don't think there's a limit, but obviously, eventually your stack is going to spit up.
There's another project called Elastic Kin, I think, Elastic KNN. It's like approximation of nearest neighbor search. Have you heard about that at all?
No, actually.
Okay. It's not like, it seems like I'd have to research how it's different. If you go onto the Elastic community video on YouTube, there's it was about a month ago, and it's similar, but definitely not the same. Like you have to prep your indexes for nearest neighbor search, as opposed to this seems more like you're predicting with using different types of data. So the nearest neighbor search is, say, like when you go to Amazon to buy something, and you start buying watches that are digital and have black straps on them, it'll show you other digital camera watches with black straps. So that's kind of what Elastic KNN does. But this is definitely really cool as far as using it for security based things.
Cool. I'll have to take a look
Yeah,
at that.
I think there's also what's nice is you can apply it to other parts of it. If you really look at the data and you look at the multiple dimensions, you should be able to, I know, well, you should, I definitely think you can apply different, not just security at the end
Yeah.
of the day onto this. And that's what's really nice about once you get into Kibana, and the data's there and it's really in an index, and then how can you query it? Another cool feature that came out last month, you actually can do Jupyter notebooks and pull those into Kibana and use the Vega dashboards too,
Right.
which
Yeah.
would. So I really like the tying those things together where you can have this external data and pull it in, and I know that was, I know Lens has been a really big, a big feature that was really, GA'd essentially, or improved also in 7.10. But Vega's and also another one that seems very interesting, to see things a little bit more. And I like the fact that they're kind of bringing like a little more of the data science in with like, hey, you know what? If I have a notebook, I have a way to import it and you work on my data. And Elasticsearch is pretty cool too, going for the future.
Definitely.
Any other questions?
Hey, I have a quick question. Thanks for the presentation. One thing that you mentioned is that KQL is really, really. I mean, people that has a background on SQL, it's easy for them to start digging into data by using KQL. However, I'm seeing like a tendency people on trying to reply everything as they get in SQL into KQL. So I'm just wondering to see if you have an experience on this type of transformations, or how do you basically were able to do that, or just want to hear your experience, or if anyone to share that, because as I said, I being noticed like a tendency to get the same results or even apply the same set of rules with KQL.
Yeah. Well, with KQL, obviously there's I would say a lot more differences between KQL and SQL. I know when I discussed it, I was when I was at AttackCon in 2019, we had a meetup just of the threat hunters that were there, a little after party. But what's it called? That's when we really had a lot of discussions about that. And it's true. There are some operations that have traditionally been more difficult with previous query languages. And just to clarify, EQL, the event query language, versus the KQL, the Kibana query language. So EQL, I think, will make more sense in syntax, really, and just the simplicity of it. Because that's one of the nice things about SQL, I think, is the simplicity of the syntax. You can just look at it, read it. You don't have a lot of verbose markings, or something's in the wrong place.
Yeah.
And so I think EQL, I mean, if you look at it, you're specifically stating what's going on. This kind of reminds me like wheres and buys. It kind of reminds me of selects, in my head at least, but that's just my head. Because like here, for instance, network, where, network protocol. So, the where kind of tells me where in my data network protocol is. Then I want to look for DNS as the value. So in my head, I think EQL, event query language, is definitely going to win. Some more, win some people over in the simplicity of it, the syntax being a little more straightforward. Also, this is a big one for me, and it's always been the biggest one, right? The ability to look at two data sources at once, because obviously we all know, joins as they are traditionally done in SQL can't be done efficiently in Elasticsearch, in a traditional sense. I mean, you could do it, but again, you're gonna really choke your stack if you do it. It's really bad. And so I think that this ability here, where we can actually start looking at two different complete data sources. I mean, Elastic Endpoint, which is an endpoint thing, and then we got Packet Beat. I mean, you could exchange this with Suricata or Zeek or any other network source. And now we can actually look across those. For instance, one of my plans is with Sysmon, for instance, there's an exploit there's a registry exploit that allows you to create, what do you call it? Like fake Microsoft signed binaries. And one of my biggest concerns in security is the fact that we just automatically trust all of our signed binaries, especially if they say Microsoft on them. And the fact that there's like a legit exploit that you can do. But the only way to pick it up would be with something like this, because it's from very different Sysmon events where it picks up, because you got to start watching the registry at the same time that you're getting, this signed binary. Because obviously, if you can't watch all signed binaries, right? That would be nightmare. But if you look for certain registry events at the same time that you're looking at for those signed binaries, that's when you start breaking it down into those patterns I was talking about.
Okay.
So I think it makes up for the join kind of in a lot of ways, because I know that was one of the biggest debates that was going on with the sequel versus not, no sequel.
Thank you. Yeah, that's that's a hard battle, especially for users.
Yeah. It's a fun one though. By the way, Attack Poker, I'm hopefully going to get this into an alpha testing late this year. It's pretty much playable, so I'll be looking for alpha testers. It's an actual game. I'm making it on the Unreal 4 engine, and everything, you'll be able to play it like online. It's going to be on PC and mobile. So, been working on it for a couple years now, actually. And then this stuff is just, like I said, I actually was a physics major a long time ago in a galaxy far, far away. So I'm just trying to apply as many different viewpoints as I can.
And then you got to release it in Unity, I guess.
Yeah.
I don't know. Sounds like fun, though.
Yeah.
So David, Christian, and Chris, you guys can email me your addresses and I'll get some swag out to you. Either you want socks, you want the book, which is like so it isn't too bad, or a beer holder or cozy. So I'll post them right now. So, and then Christian. Do you guys have any other? I posted all the links. Let's double check the chat right now. It has all the links to the ones that Ivan mentioned in his presentation, also to Ivan's blog post, his blog on Medium, and also the Kibana dashboards with Jupyter Notebooks is also there. So here's my email.
Yeah, sorry, one last question from my side will be the PDF that you just shared for the EQL. It's really, really nice. By any case, did you guys have something for the KQL language as well? Something like tips and tricks?
I'm not sure. I haven't seen one. But
I can look for one and then we can get back to you, I guess. Are you on the community Slack by any chance?
Yes, I am.
Okay, send me a message on there. I'm IP Ninichuck, kind of like my last name.
Okay, cool. I will do. Thank you.
Just send me a PM and then we can figure it out for you. If I can't find it, I know someone who can. So
perfect. Thanks.
It's always that trick, right? You always know people smarter than yourself.
It works in that way.
Yeah, I really this was a really fun meetup. I think it's I enjoyed it. I liked the interaction. I mean, this is like I mentioned in the beginning. I really miss this part of the aspect of the in person. And I think it's really great to get some conversation going. This is the most interaction across I've had in the last 6 months for the meetup itself. So
yeah.
I think it's good. It's hopefully you guys will join again. I won't be doing February because there is the user conference, the community conference. So I typically try to do the third week of the month, so the third Wednesday, And you know, best way to learn, if you guys want to present, I'm always looking for presenters. I kind of, my little joke is, you know, it really doesn't matter the size of your cluster. It's like what you're trying to solve. And if you have an interesting thing that, you know, people can pick up things too. Like it doesn't have to be, it could be a hobby. It could be like a side project, things like that. You know, and Ivan's been, that's what he's been doing here. So um, definitely hope you enjoyed it. Keep all the posts are there. Um, it's a great community. Hopefully to see you guys again in the future, and have a great night.